In this lesson, we shall focus on the limit of a rational function. So given the limit of 1 over x as x tends to 2, and that this limit is equal to 1/2, we need to present an epsilon delta proof to show that indeed, or to prove that indeed this limit is exactly 1/2. And we begin as follows. Right, and so we note that for every epsilon positive, right, for every epsilon positive, there can be found a delta that is strictly positive such that, right, such that if 0 is less than x minus 2 from here, less than delta, then 1 over x minus 1/2 is less than epsilon. Now, what we then have here is that the modulus of 1 over x minus 1/2 is exactly equal to, taking the lowest common denominator of 2x, you divide 2x by x, you get 2 by 1, you get a 2. 2x divided by 2, you get an x. By 1, you get an x. Right, and so further manipulation allows us to actually realize that the modulus of x minus 2 divided by the modulus of 2x is one thing we can most certainly write. At this point, it is very clear that we have achieved x minus 2, obviously, as we desire it from the absolute value of x minus 2. Right, and so moreover, it is very clear, therefore, we can write x minus 2, absolute value of x minus 2, and then we can write exactly this way. And so we have the absolute value of x minus 2. Absolute value of 2 is 2, and we have this exactly. We have these precisely. We have these precisely. At this point, we're able to obtain exactly the following. We're able to obtain exactly the following. So now with this, then the only challenge becomes, in other words, we're then saying, thus what we have is that whenever we have the absolute value of 1 minus x minus 1/2, it is exactly the absolute value of x minus 2 all divided by 2 times the absolute value of x. That's what we have. But now we actually obviously desire to then say this is less than epsilon. However, we have the absolute value of x in the denominator, which we must deal with. And so now we actually obviously need to add this particular series of steps to actually cater for this. We can as well assume that. We can assume that delta is less or equal to 1. Right. Assume that delta is less or equal to 1. If then it is true that what we have is that 0 is less than x minus 2 less than 1, from the delta statement before that we got previously, we are able to realize then that this means that minus 1 is smaller than x minus 2 less than 1. You add 2 across 1, x, 3. Right, and so now we have this exactly. But now we note that this absolute value of x is in the denominator, and so we must show that 1 over the absolute value is less. 1 over the absolute value is less, and so we must consider the greater than part. We have to consider the greater than part. But for instance, I mean, all these things are positive here. So we can take the absolute value of 1 less than the absolute value of x less than the absolute value of 3. 1 is less than the absolute value of x less than 3. Right? If you take the reciprocal of this is going to be 1 bigger than this, bigger than 1/3. Bigger than 1/3. I mean, what then have we been able to achieve with this? What then have we been able to actually, in essence, achieve in this case? We would have been able to achieve the following. So we are then saying, obviously, it means henceforth, right? It means henceforth what we've got from this is that 1/3 is smaller than this, smaller than 1. 1/3 is smaller than 1 over the modulus of x, smaller than 1. Right, and so now this is a very important step for us, but also it's a step we shall obviously get to use. It's a step that we shall get to use. And so with that, we're able to then say, it is true then to then say, so that we actually previously got 1 over x minus 1/2 x minus 2 times that. And so what exactly does this mean? Well, I mean, there are a couple of ways we can write it. X minus 2 over that, your x minus 2 absolute value divided by 2, and then you can put the 1 over the absolute value of x here. So that this is x minus 2, and this is less than 1. This is less than 1. And so what this then in turn means becomes exactly the following here. So it becomes exactly that the absolute value of x minus 2 divided by 2 is less than epsilon. So this means x minus 2 is smaller than 2 epsilon. It means that the absolute value of x minus 2 is less than 2 epsilon. Okay, we have this. We have exactly that. And so then what is then the conclusion out of this? What is then the conclusion of the matter? Right. What is then the conclusion of the matter? So given, so we conclude that given any epsilon positive, choose delta as follows. So we choose delta to be the minimum. We chose 1, but also there is 2 epsilon as well. We chose 1, but then there is 2 epsilon as well. And so now what then is the meaning of this? If we choose, right, so given epsilon positive, we given epsilon, choose delta as follows. Given epsilon positive, choose delta as follows. Right. Then we have the following. Okay, so this means that then whenever we have 0 is less than x minus 2 less than delta, this implies that this exactly implies precisely the following. It implies that we actually had the 1 over x and 1 and minus 1 over 2 this way. And we actually obviously are able to remember a couple of things out of these that we've got. We actually obviously have the 2 epsilon there, but we remember that this was x minus 2, absolute value of x minus 2 divided by 2 times the absolute value of x. And so in view of these here, you would actually therefore be in a position to make further analysis of the situation. But most importantly, the two instances, for instance, we're able to see that this is less than, or we can first write the equality. We can first write the equality and say it is, for instance, the following, yeah? So you can write absolute value of x minus 2 divided by 2 and then 1 over x. Exactly this way. So that then in the end, you'd have that this is less than. The absolute value of x minus 2, we know very well. But the choice of this is actually less than 2 epsilon. So in the place of this, you're going to put 2 epsilon out of 2, and the 1 over x, the 1 over x, 1 over the absolute value of x is less than 1. 1 over the absolute value of x is less than 1. All right, this is strictly less than 1. That's what it is. It is less than 1. 2 cancels, giving us epsilon. 2 cancels, giving us epsilon. At this point, it is clear that we can say, hence 1 over x minus 1/2 is less than epsilon from this. It's strictly less than epsilon from that. In other words, right, in other words, 0 less than x minus 2 less than delta implies that 1 over x minus 1/2 is less than epsilon. Right. So that we're able to make the following conclusion out of this. We're able to make the following conclusion. Therefore, the limit, right, therefore the limit of 1 over x as x approaches 2, this limit here is 1/2. This is true as required. As required, or you can say QED, as it was to be shown. QED, as it was to be shown. Right, so it's QED as it was to be shown. Now, that is exactly what we're to do. That is what exactly we're to do. But now, just to mention something here. And now, the QED abbreviation as it was to be shown has specific meanings. For instance, well, it's actually Latin. It's actually Latin and it means quod. Quod erat. Quod erat. Demonstrandum. Demonstrandum. QED is quod erat demonstrandum, the meaning of which is normally that which was to be demonstrated. Right, that which was to be demonstrated. Quod erat demonstrandum is Latin. Right, and this here is an abbreviation to actually mean mark the end of a proof. Of course, it marks the end of the proof here. Right, so we thank you for your attention and for actually lending us your attention until this point. Until next time, take care and a very, very goodbye to you.